morning, everyone. I welcome you all to the second sections of the exploration process in using Autodesk Infraworks and AutoCAD Civil 3D for design of road and its other utilities that we're going to consider. Now, in the first sections, we're able to take us through using AutoCAD Civil 3D directly with your survey data informations. With that, we're able to explain the workflow procedure to get our alignment, surface, profile, then assembly corridor, and have design output in cross sections, outwards quantities, and also getting our sheet template for this design. So the part two of these sections will take us through the integration process of using AutoCAD 3D design document and integrate it with Infraworks to now have an as-built drawing informations, and at the same time we can review our design drawings in Infraworks and update it as such. So the part two will focus in using the integrations in Infraworks. And part three, we're going to consider another project whereby we work directly with the Infraworks by working on a site that has river tributaries so the site we need to create another 1 kilometer distance of road that is going to have a bridge component across the rivers. So in that case, we work from the scratch using the model builder. So this part two now starts. For us to now coordinate these our design documentations in Civil 3D and Infraworks, we open the Infraworks interface. And from there, as I said earlier, we can use the model builder to locate that site if we are familiar with the site. So in locating the site, you use the model builder and select the names of the site locations. And doing that, the location of this site is in Kuje Area Council in Abuja. So when I select it, it will take me there directly for me to see that this is the site that I work on. So at the same time, I'm working from the preliminary part of Infraworks, that is using it from default. I can use this model builder to locate the site. Then in the model builder, I can use the area view pattern to use the site locations. So I can know if I'm familiar with the locations, I can capture the environment. This is the location I'm dealing with. So what I can do is to select the area of the locations. And when you are using the model builder, you can only have a maximum of 200 square kilometer area to select. So you use your rectangular pattern to select your lines of work areas. So, and the thing will be giving you the sizing of your increment of your selected distance. So this is how I can use model builder. When I use this, I can now give it a name and create a model which will be generated in the cloud. So, and I have to wait for it for some time to generate the content. And after generating the content, I will now download it. So while you are working with this process, your internet must be connected. So because I've done it now to save time, this is what I created after the cloud services give me the information how to download it. And when I download it, I achieve these objects. These are the details of my achievement. So you can see the site. These are site locations. Although these, so I have So you can see this is site locations now that I'm working with. Now remember, I've coordinated this with Infraworks initially, so this is my location site. The model builder will give you some default road outline as you have it from your captured areas. You can see you have several. So you can also need to integrate those services. These have been created. Let me just recreate this process again. Now, when you decide with that, this is what you're going to have in the image from the model. You can see we have this. And these are the details we have Already there was a default road pattern along this line before it was removed. So we have these information here as stated. So in order to generate the location of that site, because here the model builder create a road that is existing on this platform. This is the location I'm driving at. It has been deleted. You have something like this, which you can convert to a component road. All these are the default outline by the model builder. So the actual site location is there. So now what I will do is, for me to work with this, I can decide to import the drawings, this directly to make it easier. I can also import the IMX file that I save it as. The IMX file will show me all the design profile details as carried out in Civil 3D if you are importing it as IMX. But if you are importing it as land XMLs, it will give me the terrain which I can convert with other components. But now I prefer to import the Civil 3D drawing directly, which will make my work easier in order to avoid the issue of geospatial references that is not being coordinated in cases with IMX and land XMX. But in cases where you work with the exact coordinate system, then you can as well use those other two methods. But in cases where you are doubting it, you can save the drawings and work with your drawing informations. So now here I will import the drawing file, and in the import data I can select import AutoCAD Civil 3D drawings. So the drawing is located in my document that as training project file. So I open it. So it will come up and give me some information. And the information is text. So the drawing contains the road, the existing surface, which can also be imported, and I have the road corridors as designed in Civil 3D. Then I also have the corridor coverage area. The coverage area is the extent of the offset I have, inclusive of the assembly build up. So all this thing is what I need that I can import it into Civil 3D. Now it has been imported. So what we need to do, you can see, look at the specs here. We need to do a coordination, a configurations to state the model builder give me the site location. You can see I have this. So now with this now, I told you I already explained the outlines of road I have. So these are the defaults. When you click on it, these are showing default outline which can be converted to a component road. So from here now, I can now decide to now import my AutoCAD Civil 3D drawings using the source data or data source. So data source, then I will able to import. I prefer to import AutoCAD Civil 3D drawing because I already projected, give it the coordinate systems, so I can import it directly. So what you click on the drawings, they import the drawings that are training projects, open it. And when I open it, I have the drawing now contains the road that I have designed for, then the road existing surface, which was created with the surface data. Then I have the road corridor, we define the corridor extent, and also we have the road corridor coverage, considering the cross section offset, inclusive with the corridor. So if these are the things you need, you use it. If you don't need any of this, you remove it. For instance, I decide I may not need this corridor offset, then I can remove it. So then I can also include it. So let's go next. Now I've loaded the drawings. Then the next thing is I can need to configure the settings, configuring it in terms of giving the exact projection. So it's UTME32. Then I close it and refresh. So that the refresh, you can see this problem always comes in when those partial reference are not valid. If the reference points were not actually located for what you have from the model builder. So in this case, we have my own drawing. This is the default builder. I can delete that one. You can see my own information has been imported. This is what I have, but it's giving me a default corridor build up. You can see I do that such. It does not translate to what we define in the assembly. You can see. So this gives me the exact details I have from my Civil 3D interface. I can check the profile to view what was created. You can see in Civil 3D, this is what was created. You can see the slope, and you can also see the K values. Let's check it now to check it in line with the what we have. So now what we have here, you can see I only create one sag curve. So this is what we're showing here, and these are the details. You can see the K value. So in this case, I can even do the same thing here, do modification here, and upgrade, create another curve pattern. So you can see the length, and this is the endpoint. So it's based on the information you have in your Civil 3D that the information is coming up. Let's check the profile. So you can see, look, this is the profile. Same thing we have in the drawings is what we are seeing in the Infraworks. So the exact way I did my profile is what I'm visualizing here. You can see the details. K is same thing. The length, this are the same. You can see. So you get the exact information. So now what you need to do here is now to configure your as-built drawings. You can modify it from here to give it an as-built information. So since we are working directly with what we did in Infraworks, I can check this and even use to show the cross-section view of it. You can see. So this cross-section, you can see that one of the challenges you can have when you have Infraworks, the cross-section here doesn't translate to what I have in my 3D drawings. You can see when you look at the 3D drawings, the cross-section that I use to define my distance is this, which is just this 3.65 for one single carriageway and a drainage. But the default is giving me doesn't translate to that. So you can do a modifications to these sections here to reflect what was done in Civil 3D. So how can I modify my tools here? Now, for instance, I decide that, okay, for this street road, I want you to have a median. So considerations to modify it, change some of the, well, I just use this to explain the workflow. Then to have the median that have street lights. At the same time, I want to have that single carriageway and also have the drainage infrastructure. So in this case, what I will do is I'll click on it and adjust the settings by creating add road components. So the road component I'm adding is the median. In continuation of the second sections, we will continue from the corridor build-up in Infraworks. So as stated here, this, because of the recording process, I have some build-ups. So we have created the corridor details we want. For instance, we have a median that has this content. And this content is going to have show you the details it has. And this is the road at the site. So we can pick each item and modify it, for instance, and this imply I can replace the component, and the details of the component is just a median of 1 meter width in terms of depth of 0.3, and the slope is flat, and there's a grass area. We can as well replace the content here to a concrete entity by using the replace component, or you delete the component out of it. What you are seeing here is a sort of transformer line with street light patterns, and they are known as decorations. Decorations are features that you can put along your road corridor or part of the infrastructural utilities. For instance, the street light we have there, before you create it, when you click on it, you see the details of the street light. Then this light shows that it has a starting from the beginning of the road, and the spacings for this line is at 30-meter interval spacings for the street lighting and also for the transmission line. You can see the top edge here showing that. And there is no vertical streamline, and the stream offset, that is the offset to the left or to the right, is 0.5. If I taking to the left, use negative minus, to the right positive. So all these things is what you can create in your corridor build-up. And in the road pavement, from the median and to the decorations, we have the curves line. The curves line will give us the details of what curves to use. The same thing you have in your assembly build-up in Civil 3D. The curve line, which is 150 mm, we have 0.45 depth. We have depth below, that is completely this. If you have, for instance, you're going to have depth below, that is the line down with the median. But if you want to have the spacings in between, then the depth below can be specified as 1.3. So all these are the things that we applied in like assembly in Civil 3D. At the same time, we use it in Infraworks to create our own assembly. Now, other things have is the lane. The lane we're saying is 0.6 to 3.65, something that you build up in your Civil 3D from the sub assembly build up. You can as well do it here in Infraworks. Then we have 0.365 for a single lane, and we also have the depth for 0.4 that comprises 150 mm of sub base, 150 mm of stone base, and 60 mm of binding course, 40 mm of wiring course. So it's sum the total depth of the pavement structure as 400 mm. In terms of meter is 0.4 meters. And we have a slope of minus 2.5, and it's giving us for the right and to the left. So in this case, I choose that after that, the next thing I should have is a sidewalk. A sidewalk is a walk line where you need to have this. You can see sidewalk, remember the walkway along the road. But before the sidewalk, you can input some other informations on this corridor line. And this information you can import is the curb, because there must be a curb before the sidewalk. So in order to modify this, there's what you can do is to click on this. You can remove this as well. At least any component it can be replaced, it can be split, and it can also be deleted. So when you delete this component, then you can create the curb before the walkway. And in creating the curbs, all what you do, the select the corridor. You can go off it. You can see lines to the intersections. Select the corridors. Then you can click and you click on insert road component. Road component I'm inserting is curves. Now when I select it, then the side of the instructions will be shown. Let's put it here. Then after that, then you define the parameters. The parameters will state in terms of width, we have 0.15, in terms of depth 0.45, depth below we consider 0.3, that is 0.15 will be above, and this one will be down. Deflection back end, no deflection, so we have no face deflections. Then when you do that, you can as well, before you extend it, you can as well check what you have in the provisions. When you click on it, you can see how it's being shown, and you can see, look at the curve, like you can see 150 as the top of the road. So this need to extend to the end. We click on it, click, then I click, then you select this, click here. So end of road, then the other one, the beginning, will reflect this thing to extend to start of road. So complete the curb line, state that. You see? There are other things you need to add here as well. You update it, the information will update itself as well. So we see it's on the updater. So the other things you can have within the curb lines is The other things we can have is the walkway. So to do the walkway, what we need to do is just select the corridor of the road. This being a single, we have it. Select it. Right click on it. Then we create an insert road component. And this component of road we want to start is a sidewalk, otherwise known as walkway. So the side we want to put it, you shown it here. Then you define the parameters for the walkway. Then this, let's say, is 1.5, or let's say the walkway is 1.2. Then the depth in terms of the pavement is 0.3. Then the slope is 0, 0. Then we as well show the informations. You can see, so the walkway needs to be extended to the end of the road, and also extending to the beginning of the road. We see it clearly now. So we can update it as well. You're double clicking on the surface. Then when you check it out now, you see this. Now what we're seeing by this edge is giving us in terms of cut, in terms of feel of the embankment, the slope pattern. If we don't need this, it can be modified because the terrain has to adjust itself. So the adjustment of the terrain, you can see we've created the walkway here. I'll only demonstrate this on the left side, on this side, or whatever I did here can be replicated on the right side. Then I have a curb lines before the walkway. Then at the end of the walkway, I still need to have a curb line. So I need to add a good component again. The same curb lines will be added to complete at the head of the select the point of attachment, then define. Remember, there's a mistake here. This is not what I want to click. What I need to click is I can replace the component if I made a mistake. The component I want to put in here is a curve. So I choose it and I replace what was shown here, which was mistaken as a sidewalk. And I did this curve line to have a width of 0.15, that's 150 mm, 15 cm. Then as well I can update it then to change. So irrespective of making any mistakes, you can as well replace that mistakes with the actual things you want. So define the curb line to the start end of the road and at the same time to the start of the road. So complete the site for the curb activities. So we have it as such. Now you can see it can be completed, stated, and I've defined it. Where you have intersection, there will be a big line. You can see where you have embankment stated, and where we have joint line, the intersection, you define it. So where you have embankment field, because when you look at the corridor, we set the limit for the grading method as set here. Or you can also use the slope conditions. So you can set this in terms of fixed slope or fixed ridge. Whatever desired pattern you want to use, you can as well use it. Furthermore, in order to explain how we can create our the road to road intersecting, for instance, this is a converted road design, and this is a typical model builder's treatment of this road. So for you to make it join to intersection, just click it to the other road, then it will convert to an intersection line and divide this line for you. This is how simple for you to use the Infraworks to do intersections. So this has been concluded. Now we have a corridor sections as defined in this pattern as stated. I only work towards this side. At the same time, remember, one of the challenges when you're relating with Civil 3D in the Civil 3D build-up, we have an open China coordinations. But the essence in Infraworks support not open China's because of the ability of our unit services. It gives us an underground collection of water. And this pattern You want to add a draining pipeline, it must have a manhole and wet it to discharge underground because that is for sustainability approach. I think when we get to defining and the part three, whereby we define all processes of creating drainage systems, your hydraulic structures, including culverts and bridges, will explain further on the drainage patterns and how you can set your inlet and the outlet for each culvert, how you can define the different types of culvert, whether the box culvert or pipe culvert. It should be discussed in the part three of these recording sections. Now, again, the next thing we need to consider is to, for instance, if this has been a completed road corridor details, I can do what we call a storyboard review to do a walkthrough. But before the walkthrough, the other things I can do here in exchange of using Infraworks, because when you're using Infraworks, you have to be subscribed. You will subscribe in order for you to have cloud services. And cloud services ensure that you do what we call design optimizations, and at the same time, we do mobility simulations. At the same time, we can do traffic simulations. So all these things are connected. When you're doing traffic simulations, it will display you are seeing cars moving in the directions of the road. And this is also good when you are working, when we are creating, designing intersection or interchange, whereby we have clover leaf interchange and diamond interchange. All this will show the pattern of the road traffic movement for you to understand the movement of traffic within those intersections and roundabouts. So in this case, if for you to connect that, you can as well go to practice simulations. So your practice simulation, to access practice simulation here, you need to publish your model. And when you publish your model, it will take it to the cloud and it will you have to use the document management for you to access the simulation process. So that's why when you check the pattern of you check what services you have from your information, you can as well find those things that you need, all those add-on and extensions you need to connect. So for doing transformation, how to connect to the BIM 360 collaborations, you have the documentations, and from the connections, I load my information in the cloud, then choose a select pattern analysis I want to use. So I can go further into that. The same thing when you're doing your corridor optimizations, select the design speed coordinations and click on it, select the lane pattern you're choosing, and you optimize the design with the criteria statements. All this will not go into that because of the time factor. Then your program view statement has been shown. For this road, you have to click it, then you can do all the design changes from here. It's very flexible, and when you change it as well, you need to change it. You have to export it back at IMX into your Civil 3D environment, and all this information will update itself. But another thing that we'll talk about here is to now show to us how we can do a storyboard creation, where I can do a walkthrough on the road. For instance, we have the storyboard creations will allow you to create a walkthrough for your road. You can select the walkthrough from the approaching camera from different patterns, from hard frame animations, up animation, pan animation, and record walkthrough. You can create it as well. You can also use create it from the component road that you designed. And if you create from component road, what we do need to do is you create the road and we also to click the component road to follow for the camera path. When you click on it, it directs us to what is the view from the point of camera positions. You can as well do a preview check on what you're supposed to see. For instance, at 00, what's my preview level? Showing that I'm going to see my road details in this pattern for me to coordinate a walkthrough. Then at 20-meter horizontal offset, I'm going to see this. You can use preview to guide you on how pattern you're going to see in these directions. And at the vertical offset, if you click 50, you see how to change this pattern. Then I can going to see the camera path line from these directions. In most cases, for a walkthrough, for a to do a walkthrough or for a design, then you always make use of the camera position offset for horizontal and vertical offset. Now you can set the speed of movement to the so that you can see it. You can make it slowly, you can make it faster. So as long as you finish setting all these parameters, all what you need to create is to create a camera part with this setting. Creating the camera part, it automatically generate this information for you for that road information. Then you can use the storyboard player to select the plane's pattern in order to overview to see the walkthrough of this video. It's always good to use this method to present to stakeholders, to approving authorities, to government agencies of a preliminary design, showing all relevant infrastructural information that you need to present. It's good because they will understand it better, they will appreciate it better, and they will understand the cost implication that involve in infrastructural project. So these are certain things that you can do with Infraworks. So when you're able to check your walkthrough, you can now determine to export this into a video, convert it into a video component if you are okay with it. In this case, we're trying to put covers, but as I said, in the part three of these sections will focus on all the auxiliary structure, how you can create road component that you put your cover type for the pipe covered, for the bus covered, and also the drainage patterns for the underground piping with their manhole and collections point. And also I can create a bridge pattern on the river lines, and I can design that bridge pattern, make it become a redesigned bridge with other component software like Infraworld Model Builder, Inventor, and also Average with advanced steel. So all these are things that we're going to explain in the part three. It's a little bit complex, but at the same time, we'll look towards for your part three, which shows most advanced application with this. But the next thing now is for me, if I want to convert the video, just a quick overview is to go to export current storyboard and I can use the encoder method. I always use most cases video. I can set the parameters to state the viewport resolution or set the resolution as I have it by default, and I can also export any kind from this section to sections. Then if I'm exporting all the road, I can just hit record. And when I can record, I can give it a name where I want to put it in my in my document. And we have this as a Kude video walkthrough. Yeah, Kude road video walk. Sorry, video road walkthrough video. So I save it in this, then I now record it. So the thing will record itself and to transport all my walkthrough to the encode it into video format, which I can play directly from any video media player. So the recording is proceeding. So now it's coming to an end. The recording, because it's a short video recording process, and have it as well. So it's completed, the video recording is finished. So as well, I can just go back to the informations and I put all shows the recording procedure for the videos as well. So this is the Kude Road walkthrough. I can play it with the media player, then it's giving me the walkthrough of the design road in Kuje site. So we're going to round up the second part two sections of this recording process. You can see all this where you see the adjustment, all we need to go back and connect those intersections that are not in line. You can see I see some little check that's showing some details that are not in line. Make corrections and do your recording again. So you can as well see all the intersections. Then these are the mistakes. Take note. I have to remove it later. We explain it in the part three. So we have a review of the video sections, and the next thing is just to just quickly look at some work, walkthrough. Let's look at some of the walkthrough we've done in terms of presentations, in terms of slides, and in terms of locations. We can see some of the walkthrough. Let's check it out. Of the site, and you can see of a design that has been done. You can see the one of the advantages of model builder is to give you the pattern of the terrain conditions. Let me fast forward it. an overview of how the site look like, the building. So these are samples of walkthrough creations videos. You can see them here. All these points can be removed. And you can see bridge. As I said, the top part 3 sections will explain how we can work with our bridge mode. You can see covered at this point. Just check it, you can see us. So you can see these are the things we're going to explain in the part 3 sections. How you can put covers of road patterns. So, and also the bridge, I can put bridge informations and other details. And you can see, you can go through the walkthrough. So it says a lot of things about this. So we can as well see all the things we've done. Other walkthrough that we can also check out is what we've done before in order to give you a quite things that we expect to see in our videos in the next sections, where we're going to consider roundabout, intersections, and hydraulic structures. Now, for hydraulic structures, I will quickly show us what you can expect as a walkthrough, and this one is giving us this. So, in what we are going to discuss on the part 3 of these sections. You can see. So these are some of the things we consider designing bridge infrastructure. You can see it's a girder bridge, how it was created. So component